In this lesson, we're going to look at some of the libraries that Java provides and the documentation that goes with it. Well-encapsulated objects are generally easier to use than libraries that consist of a bucket of loosely associated structures and functions that operate on them. The reason is that the object should take care of itself as much as possible. So, with structures and functions, it's often unclear if there are rules about which fields of a structure are required for input to a function, and which will be provided as output from the function. Also, it's often unclear if you are supposed to invoke certain functions in a particular order, or if a function must be called to set up another one. While it's perfectly possible to have trouble understanding an object-oriented library, some libraries deal with intrinsically tricky issues, and some programmers create better libraries and better documentation than others. You should still find that in general, OO libraries are reasonably easy to understand. Like any software, names in OO are important. In an OO library, if you have an object called duck, it should be a model of a duck and nothing else. If the duck has a method called quack, then it should make the duck quack and nothing else. The duck should not fly away, nor eat, nor any other behavior. It should just quack. What this amounts to is that if you look at an OO library and you think that you have a good idea what something does based on its name, then there's a good chance you're right, and there's a good chance you'll be able to use it correctly. Let's start by looking at the documentation that Java provides. Point your browser at this link, http://docs.oracle.com/java.se/7/docs/API. Notice that this resulting window is split into three parts. In the top left is this list of all the packages available in the core Java distribution. Each package collects related classes that work together to solve a particular problem or family of problems. Some of them have suggestive names, such as java.io. Here you can probably guess that this relates to I/O operations, like reading and writing files. Some of the names are less obvious, like java.awt. This actually provides the Abstract Window Toolkit, which provides very basic tools for creating windowed interfaces with buttons and text areas and the like. Let's click on the java.lang package. That's here. This contains classes that are tightly tied to the language itself. Notice that the frame here in the bottom left corner just changed. This now lists all the elements that are part of the java.lang package. Let's click on string there. See that the frame on the right now shows the documentation for the string class. Most of the classes in Java will have a description of the class and perhaps even examples of how to use it in this top section. Though it's only fair to note that some classes are not well endowed in this respect. It varies with the programmer who created the class. As we scroll down, we come across a list of all the constructors for the class. There's constructor summary. So we see we can create an empty string, or we can create a string from an array of bytes, or an array of characters here, or perhaps as a copy of another string. This one here. There are a lot of these constructors, and many of them are actually quite rarely used. Scrolling down further, we find a list of the methods that are available for a string. Some of these are simple to understand and we'd be likely to use. Others are rather more obscure, and the chances are we wouldn't need them. So we can probably see what char_at might do, and similarly the compare_to method down here. But we might need to do a little more research to know how to, for example, use format down here, and the matches method here. Further down still, we get a more detailed description of each of the constructors and methods that are listed. Clicking on the short description will actually take us directly to these longer descriptions, so we can see them immediately. There's also a section between the short and long descriptions. Methods inherited from something. Sometimes a class will have more than one group of these inherited methods. It turns out that object-oriented languages allow us to define a class in terms of another class with extras. That means we don't have to copy and paste a whole lot of code to create a new class that shares much of what an existing class provides. It also has some interesting consequences, since object-oriented languages consider that if one class is defined in terms of another class with extras, then we're allowed to substitute the class that has the extras in place of the original class. For example, if we created a class called person, and then said that the class VIPPerson is a person with extras, Java uses the syntax class VIPPerson extends person, then we can create an array of person objects and use it to store a mixture of both person and VIPPerson objects. This lesson doesn't intend to go into those details, but you'll need to understand that sometimes a method that you want to use might be defined in one of these methods inherited from sections. And it's okay to just go ahead and use those methods just as much as the ones that were defined in the class you started with. Before we wrap this lesson up, let's take a quick scan around and look at a few more samples of documentation for classes that you might want to use. Let's look at this integer class here. Notice that there is a method in here, parseInt. Passes the string argument as the signed decimal integer. If we look at this one in more detail, we'll see that it also says throws number format exception. Many methods might fail in certain situations, and the exception mechanism is how Java expresses that. We might also look at, in the math class, the random method. Let's click on this one. Returns a double value with positive sign greater than or equal to 0 and less than 1. So this one would allow us to create simulations that might be useful in games and so forth. Let's take a look at one more. We'll go to the java.io package and we'll look at the file reader class. And notice that we can create a file reader based on a string. And that says creates a file reader given the name of the file to read from. We can also see that a file reader provides, in the inherited methods, the ability to read. So we can read into a character array characters from a file. So, in this lesson we've considered how object-oriented libraries can be easy to use, and we've looked at the structure of Java's library documentation along with a few specific examples of useful functionality.